Welcome to the RAOB program's Cloud Layers and Options. Please note that this feature and associated cloud graphics require use of the optional Analytic module and one short example with the optional Cross-Section module. This video will show how to display cloud data on soundings and on cross-sections. And then we'll see how you can edit cloud data using the unique cloud layer table. But first we'll see how to plot cloud data on the sounding diagram. To do this, we need to use the toolbar. We could use the Analyze menu option, or just use the mouse by right-clicking along the left margin of the diagram. And then just click the Clouds button. Here, drawn in a dark gray color, are the cloud layers. These cloud layers are automatically determined as indicated by the auto text as seen on the Clouds toolbar button, and as seen in the above cloud column label. We'll discuss these a little more later on. But now let's look at the stepped cloud layer region, where cloud coverage is represented by the width of the gray regions. For example, the first bar indicates few clouds. The second region indicates scattered clouds. The third region indicates broken clouds. And the last region is an overcast cloud layer. RAOB determines cloud layers using a traditional dew-point depression algorithm, which is detailed in the optional User's Guide and Technical Manual. For an example, we can show how this works by expanding the thin cloud layer found just below the 700 millibar level. We'll close the toolbar, and then we'll click and drag the lower sounding data point back and forth. And you can see how the cloud layers are automatically being redefined. So let's return to our original sounding by using the Restore menu. Not only does RAOB determine cloud layers, it also identifies cloud types, which is primarily a function of lapse rate and height data. And we can see this information by selecting the Listings menu. Note you can also call up the Listings menu by just pressing the spacebar. So now we'll look at the Complete Listings tab, where cloud data for each sounding level can be found. Looking at the plotted sounding, we see a thick cloud layer at around 550 millibar. So we'll scroll down the listing until we find 550 millibar, and there it is at layer number 7. And there at the end of the fourth data line for the 550 millibar level is the cloud data, which shows an overcast layer of AC, or altocumulus clouds. And here are just a few more examples of some other found cloud layers. Okay, let's close the listings views, and now we'll see how cloud data is displayed on cross-section diagrams. To do this, we'll go to the Displays menu and then select the cross-section option. Here we have a cross-section dataset already loaded. It is a time-height diagram. So we'll just use the Analyze menu to access the toolbar, and then we'll click the Clouds button. Since this display is just using the standard cross-section module, the cloud analysis is only performed with isopleths. The legend of the cloud labels is listed at the bottom of the diagram. Now we've activated the optional Advanced Cross-Section module for additional analysis options. First, we'll recall the toolbar with a mouse right-click and then use the Clouds button again. Now we can see that the clouds analysis is drawn in a colorized format with shades of gray. And when we again click the Clouds button, the clouds isopleths are now drawn on top of the shading. And to study any of these individual soundings in greater detail, we can expand any one of them. So we'll close the toolbar and then hover the mouse over the 20th hour, for example, and then click the mouse to see a mini sounding image. And now we can click the expand box icon for a full screen sounding diagram. And here we have our expanded 20th hour sounding. And when we call up the Soundings toolbar and click on the Clouds button, we can see its cloud layers plotted. So before we move on to the last segment of this video, let's recall our original cloud sounding by using the File menu's Quick Recall listing. And again, get the toolbar and apply the clouds analysis. Okay, for the last section, let's look at the cloud layer table. In order to use this table, we'll select the Options menu and then the Cloud Layer Table option. The main purpose of this table is to allow the user the ability to override RAOB's automatic cloud generator and edit individual cloud layers as needed. This is critically important for forensic analyses involving aircraft icing and other related research. Okay, let's start at the top, where we can see the default automatic cloud determination method is active. The other manual method will be discussed a little later. The Use Cloud Data from Source Sounding When Available option can also be seen on the Program Options panel as seen here. And here is the same Cloud Source option as seen on the Algorithm Options tab from the Program Options panels, which has its own video. Okay, now let's look at the Clouds button, which shows the altitude logic table that RAOB uses to classify each cloud layer type. Height units are in hundreds of feet AGL. Before discussing the listed cloud layers, let's look at the information at the bottom of this table. It says that the Smith-Fettus icing method is currently employed. This information does not affect the cloud table, but it is only a reminder that the cloud layers defined in this table directly affect how icing and precipitation are analyzed. In particular, the icing algorithm options are found here. The icing options are listed on the same Algorithm Options tab from the Program Options panels next to the previous Cloud Source option. Okay, now let's talk about the actual cloud layers. First, notice that the heights are in hundreds of feet AGL, as listed in the two columns used to define the cloud's base and top limits. So to better reference these cloud layers on the sounding diagram, let's change the vertical coordinate from millibars to feet. So we'll first close the table, then right-click to call up the sounding diagram options. Then let's look at the Format tab to ensure we're using the AGL mode. And now look at the Pressure and Temperature tab and select the Feet Grid option. And let's also select the finer interval setting of 1,000 foot intervals. And while we're here, let's shift the sounding profile to the left for better visualization by manually adjusting the temperature's minimum and maximum scale limits. Then we'll apply and save as default, and now we can again select Options and then the Cloud Layer Table option. Okay, now that our vertical coordinates are the same, let's examine the system-generated cloud layers. The first layer shows a thin stratus layer at 5,400 feet. This is reflected on the sounding diagram by this thin gray bar, which is a result of the single data point on the soundings profile. And now let's look at the last, or ninth cloud layer, which shows another stratus layer with a base at 18,500 feet and a top at 18,700 feet. This is a good time to point out that while RAOB may automatically generate many cloud layers for any sounding profile, this cloud table will only show the first 9 cloud layers. And it just so happens that this sounding only has 9 cloud layers as indicated here. Okay, it's now time to demonstrate the manual method. To do this, we'll click the Manual option, and now we have a new column of Options buttons. And we'll begin by removing all the cloud layers. But look, the sounding still shows the cloud layers, so we now need to use the Apply button. And notice that the cloud graphic is gone, and the cloud title now says No Cloud, with a small manual indicator just below. And when we recall the toolbar, it also shows the manual indicator within the Clouds button. Okay, so let's manually add some clouds. We can recall the cloud table just by right-clicking on the Cloud Toolbar button. Alright, let's assume that we have independent observations of a broken cumulus layer in the 11 to 14,000 foot region. And we want to perform post-analysis studies. So let's click the Add button, and let's enter a broken layer of cumulus clouds from 11,000 feet to 14,000 feet. And now, to see the cloud graphic, we'll select the Apply button, and there's the new cloud graphic. And now we'll right-click the Clouds toolbar button to return to the cloud table. Before ending this video, it's important to note that RAOB will always determine cloud layers using the default automatic method. If, however, you access this cloud layer table and select this manual method, and then save the sounding with the Save button, then the next time the sounding file is recalled by RAOB, the manually entered cloud layers will be recalled and plotted. That completes the RAOB program's cloud layers and options. Thank you for watching.